Hello, today's lesson is 14-8. It's called Same Area, Different Perimeter. Tough lesson today. Wow, so thank you for watching the video and reviewing this. You have found the perimeter and area of rectangles. Today, you'll learn how rectangles with the same area can have different perimeters. First, we'll review two terms that can be easy to confuse. What is area? What is perimeter? How are they the same and how are they different? Well, they're the same in some ways and different in some ways, and that's what this graphic organizer kind of lets us explain. So, to find area, we multiply the length, that's this side going across, times the width, that's this side going up and down. For my example there, 5 by 5 rectangle, we multiply 5 times 5 to find the area. Another way of thinking about area is that it's all of the units inside this shape. All of these count for area. Perimeter is different because to find perimeter, we add the length of each side. So for example, in this rectangle that we have on the screen, we would add the lengths of the sides, 5 plus 5, plus 5 plus 5 again. So I gave students some squares, some tiles, and they needed to arrange the 12 tiles they got to either make the biggest perimeter, or they got blue tiles, same number, 12 in this bag as well, and they needed to arrange them to make the smallest perimeter rectangle. So here's what they did. For the red, when they were trying to make the biggest perimeter possible, they put them out in the longest, skinniest rectangle they could. They put it in a rectangle that is 12 long and 1 wide, 12 by 1. I did yellow as an example for the screen, although we didn't have yellow tiles. And then for the blue, if they were trying to make the smallest perimeter, they made it more like a square shape. They had 4 across the top and 3 down for a 4 by 3. It's still the same area, because if you look, all these rectangles have 12 units inside them, but they're different perimeters. Students found that the area was 12 for the red, but the perimeter was 26. That's 12 across the bottom, plus 1, that one makes 13, plus 12 across the bottom there, plus 1 makes 26. Here the area was still 12, but the perimeter was down to 16. The edges are 16. Here the area is still 12, but the perimeter is 14. 4 plus 3 plus 4 plus 3 makes the perimeter. So what do you notice about how the shape of the rectangle changes the perimeter? Longer, skinnier rectangle is a bigger perimeter. Shorter, more like a square rectangle makes a smaller perimeter. Why is that? We puzzled over this for a while, and then we realized what's happening here is that you're taking what was the perimeter, these little edges that touch the outside of the shape, and sort of folding them inside the shape. Like for example, this line right here on the top of the 5, it's a perimeter piece on the long skinny rectangle. Down here, that same line on the top of the 5 is no longer counted for perimeter because it's tucked inside the shape. There's so many edges tucked inside the shape here that they just don't count for perimeter anymore. Longer, skinnier rectangles have bigger perimeters. That's one thing we absolutely have to remember for today. So here is a problem that we did as a class. Park School and North School cover the same area. In physical education class, that means in PE, each student runs 1 lap all around the school. That means they run the perimeter of the school, don't they? So that's what the kids at Park School run, around the perimeter of that rectangle. Kids at North School run the perimeter of this long skinny rectangle. At which school do the students have to run farther? In other words, which perimeter is longer? Park School perimeter longer or North School perimeter longer? Pause the video to think about this if you need to. North School runs farther because they have a longer, skinnier rectangle. Longer, skinnier rectangles have bigger perimeters. Rectangles that are more like squares have smaller perimeters. Okay, here was a tough one that we worked on as a class. The perimeter of rectangle P is 12 feet. The perimeter of rectangle Q is 18 feet. Both rectangles have the same area. Find the area and the dimensions of each rectangle. Dimensions means how long the sides are. I gave students a hint by giving them 8 squares. They kept their bags, but this time they only used 8 of the squares. We left 4 in the bag. With those 8 squares, we first made a rectangle with a perimeter of 12. So take 8 squares, and you can do this on notebook paper if you need to. 8 squares and make a perimeter of 12. Once you've done that, take those same 8 squares and make them into a rectangle with a perimeter of 18. Here's what it should look like. There's perimeter P, or rectangle P, I'm sorry. Perimeter is 12. There's rectangle Q, perimeter is 18. Remember that the more it's shaped like a square, the smaller the perimeter is. The longer, skinnier the rectangle is, the bigger the perimeter is. So I also wrote down the answers to these questions. The area is the area is 8. The length is 4 because across the top we have 1, 2, 3, 4 for the perimeter. The width is 2 because going down we have 1, 2. Here the area is still 8 because we're using 8 tiles just like we did before. But what's the length? Count across the top. What's the width? Count down. Length is 9, width is 1. We looked at a couple of these questions for the textbook. We used grid paper to draw 2 different rectangles with the given area. We told the dimensions and the perimeter of each rectangle, and we circled the one that has the smaller perimeter. So I wrote that out in bullet points too to make it a little bit easier for students to understand. We're going to be looking at number 7. We're going to use grid paper, which I gave out. We're going to write the question number, so start by writing 7. We're going to make 2 rectangles with the area given in the book. 2 rectangles, both with an area of 9. We're going to tell the dimensions, in other words, what the length and the width of each rectangle is. We're going to tell the perimeter, and then we're going to circle the rectangle with the smaller perimeter. For number 7, when it's 9 square inches, you could have a rectangle that looks like this, 3 across the top, 3 down, and that could be one of your 2 rectangles. Then you could have a rectangle that looks like this long skinny guy, 9 across the top and 1 down. And then we need to tell the length and the width for each and the perimeter for each and circle the rectangle with a smaller perimeter. These questions were tough as well. 11 through 14 was also tough. We wrote each question number. We found the area for the rectangle that was shown. So here we do 6 times 4, or 24 for the area. And then we told the dimensions, the length and the width for a different rectangle with the same area. And then we said which rectangle has the smaller perimeter. These are the questions we did today, and that was it.